What's up, Math 6 students, or whoever it is I'm talking to right now? Chapter 9, Section 1. This is the introduction to statistics. I love this chapter. Statistics are super interesting because they can be used to analyze things like people. And if you've done the Flipgrid today, which is on pets, this will be very much useful to you. So the essential question for today is, how do I construct a data set? Data set. I like that word data. Does it make me sound like a big nerd? Hopefully not. Okay, how do I construct a data set? So we'll be able to answer this question throughout today's lesson. What is the meaning of the word statistics? It's a word that's thrown around a lot. Math breaks into lots of different like subtopics. You have things like algebra, you have like statistics. And really what we've been studying mostly in class is algebra, some geometry, and now we're going into statistics. And statistics is the science of collecting and organizing and analyzing and interpreting data. And we're going to construct a data set today so you'll see what data means. And a statistical question is one for which you do not expect to get a single answer. So you do not, I should highlight that, do not expect to get a single answer. So why don't we jump right into checking whether or not a question is a statistical or a non-statistical question in the first row here. And the question is, how can you tell whether a question is a statistical question? And I'm having some trouble, scrolling troubles. Oh, the joys of online teaching. Okay, so how can you tell whether a question is a statistical question? Okay, an example of a statistical question and a non-example. Okay, here's an example. How old are Travis Ranch Middle School teachers? Do we expect to get one answer for that? I should think not, because different teachers are different ages. Whereas a non-example, so not a statistical question, is how old is Mr. Plunkett? And everybody knows that he's 83. So that has one answer, right? That's just one answer. You're not going to be able to construct a data set. So let's think about this. What is your shoe size? What is your shoe size? If you ask different people about their shoe size, then they're going to give you different answers, right? Like somebody might have a shoe size of 3, another one could have a shoe size of 112. So what is your shoe size? Is that a statistical question? Yes, it is a statistical question, right? And the idea is, I mean, if I explained, it'd say you don't expect to get the same answer from everybody. How many states are in the United States? Do you expect to get different answers? Well, maybe if you ask your little brother or sister who doesn't know how many states are in the United States, but factually, there's only one answer and it's 50. So that is not a statistical question. How many brothers and sisters do you have? If you ask different people that question, are they going to have the same answer? And the answer is yes, or no, they won't have the same answer. So, or not necessarily. And so we're going to say, yes, that's a statistical question because you'll get many different factual answers. How many US presidents have been in office? Well, there's only one answer to that. Was it 46? 47? I don't remember anymore. 45, isn't it? How many US presidents have been in office? There's only one answer. So is that statistical? No. What is your favorite type of movie? Interesting. Because favorite type of movies can fall into categories like comedies or maybe you have action movies or whatever it may be. So those are not numbers. They're not numerical. But if you ask different people, will they necessarily have the same answer? And the answer is no, they won't have the same answer. So yes, that's statistical. You can ask a bunch of different people and figure out which category of movie is most popular or whatever. How tall are you? If you ask different people, are they going to have different answers? Yes, they'll have different answers. And so, yes, that's a statistical question. All right. Well, on the Flipgrid today, I asked, how many pets do you have? And you'll never believe this, but different people had different answers, which means that asking how many pets do you have is certainly a statistical question. And so how can you use a dot plot to display data? So we're going to make a data, we're going to construct a data set, and here it is. And I see here it said, how many pets do students in Mr. Plunkett's blank period class own? Well, since we're doing all of the classes at once, this is actually 2 different periods. So let's just say, how many pets do students in Mr. Plunkett's 4th and 6th period? So we're going to do both, okay? 4th and 6th period classes own. Is this a statistical question? And the answer is yes. I'm just going to put a Y because I don't have enough. I'll go for it anyway. Oh, see, look, why do I even try? Oh, okay, whatever. It says yes. Because different students can have different factual answers. Okay, so I actually put this out there. It was on Flipgrid. Here are your answers. I had Braden, who mentioned his pet Bennett, and Kayla said she had 4 Flash, Sharkbait, Bubbles, and Zona, so that's 4. And then Sophia said she had 2, Penny and Harley. And then Christina said she had 1, and it's a cat with an amazing name, Cat. Michaela said she had 2, and that's Layla and Jackson. Jonah said he had 1, which is Remy. And Hasty said she had 1, which is Mr. Gold. Mr. Gold sounds like he's pretty rich. Dylan said he's got 2, Watermelon and Carrot. Lauren says 1, whose name is Teddy. Taylor Ann says 3, Zoe, Remy, and Bruno. Riley said she has 2, Lou and Abby. And Emily says she has 1, which is named Pepsi. I have 1, and her name is Gizmo. And just to teach you about some other stuff, I asked some other people. I asked Patrick Starr, I said, hey, how many pets do you have? And Patrick Starr said, he said, I have 10. I can't do Patrick's voice. Don't even try. And let's say I asked somebody else. I'm going to go with Camilla. Camilla said she has 20. Dang, Camilla, 20 pets? They must all be fish. Okay. What we're going to now discuss are numbers. Gather the responses of yourself and 14 other classmates. That's what you were going to do. We just did it. And record them in the table. Record any number greater than 12 in the possible outliers table. An outlier is a data value that is significantly different than the rest of the data. So you can see that everybody's data is kind of chilling around 1 to maybe 4. And then here, these 2, Patrick and Camilla, they got some pretty big numbers. It says to only do the numbers greater than 12, but we'll do both 10 and 20 because those are pretty different, right? 10 and 20 are pretty different. And so we're going to consider those possible outliers, which means that they're much different than the rest of the data. Okay, what we're going to construct here is a dot plot. You'll never believe this, but a dot plot has dots. And it's above a number line. So you can see this number line. I have 2, 4, 6, 8, 10, 12. I don't have enough spaces. I need to go all the way to 20. How to solve this problem? How about I count by 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's not bad. It's gonna get a little busy in this area, but we'll see how that goes. Okay, we'll start with 0. Was there anybody who had 0 pets? I look back through the data. Nope, we've all got animals to take care of. How about 1 pet? 1 pet. Well, there's a lot of them, right? So I'm gonna highlight those ones, and I'll do that. I'll start with yellow. So 1, 1, 1. That's 3, 4, 5, 6, 7. 7 people with 1 pet. So above 1, I'm going to put 7 dots because we're making a dot plot after all. So 1, 2, 3, 4, 5, 6, 7. Doesn't look bad. Okay, so now I'm going to go to the next number, which is 2, which is 2 is above this. So I'm going to do that with green. So 1, 2, 3, 4. So 4 people with green, or sorry, with 2. So 1, 2, 3, 4. This is really beautiful so far, I gotta say. I'm not trying to toot my own horn, but it's pretty good. All right, and let's try orange for 3. Oh, there's just one 3. So we're going to put the one little 3 there. And then 4. Look at that. There's a 4. 4. Let's do a different color. Let's do red. Boom. There's 1 4. We'll do 1 4. And then we have 1 at 10 and 1 at 20. This is called a what? A dot plot. It's got dots. It represents how many different responses were that value. So we had 7 responses that were 1, 4 responses that were 2, 1 that was 3, 1 that was 4, and so on and so forth. Okay, we're going to use the distribution of the data to answer the question, how many pets do students in Mr. Plunkett's, as I said, we're just going to say 4th and 6th period class own. So 4th and 6th. What would you say is a good answer to that question? And the answer, I'd say about 1 or 2. Why? Because that's where we see the most data, right? Most of our data is centered right there. Okay, now we have to identify clusters, peaks, and gaps. Okay, what's a cluster? A cluster is when several data points lie in a small interval. Now, you may not know what interval means, but interval means between a group of numbers. So how about from 1 to 4? Do you see between 1 and 4, you have a lot of data centered here? So that's what we call a cluster. And that cluster, you can say it's maybe 2 is in the middle of it, right? About 2 is in the middle of it. So there's a cluster around 2. There's a cluster around 2, and I'm making this 2 a little bit bigger. Oh, that 2 is just getting better. I'm glad that I spent time trying to fix that. It just got worse and worse. That's cool. A peak, like a mountain peak, is a data value that occurs most often in an interval. There is a peak at, well, between 1 and 4. Where's that peak? There it is. It's at 1. That peak's at 1. And later on, we're going to find out that that peak also represents the mode of the data value that comes up the most. Okay, a gap. A gap is an interval with no data. There's a gap between blank and blank. Well, isn't there a gap between 4 and 10? There's also one between 10 and 20. We'll write 4 and 10, and then there's another one between 10 and 20. And a gap is where there's no data, and I realized I didn't highlight, so let me try that again. A gap is an interval with no data. There's a gap between 4 and 10 and 10 and 20. A data set like this one doesn't, but a data set can have 0, 1, or more clusters, peaks, or gaps. So there may be no gaps in your old data set. There may be 2 gaps. There may be 3. There could be no peaks. There could be more than 1 peak if you had different clusters that had a highest point. So keep that in mind as you go. Okay, I'm going to end this for part 1 of 9.1, and then we'll also do part 2 in just a minute.